Functional interfaces, right? What are functional interfaces? We have seen, right? Supplier, predicate function, right? Consumer, right? In streams. Today's class will start with the streams. In streams, it will use all those functional interfaces, right? Internally, it will use all those functional interfaces, right? This is introduced. Streams are introduced in Java 8. Functional interfaces, streams, lambda expression, right? These are all introduced in Java 8. Right. What are the advantages of streams? Why we need to use the streams? Right. Streams are mainly used to process the collections. Like, right, we have different types of collections list set, right? Right. We can use streams on that collections. We can process the data. We can process the data. That means you have one list, right? Suppose I have a names, right? List of names. I want to filter from that. I want to filter from that. That starts with A. Our length will be greater than 10. Right. Our names contain something. Right. How we will do usually we will write some for loop and if conditions, these things. Right. Instead of that, we can write in a simple way by using streams and also we can process the parallel stream. Suppose you have a list contains 1,000 names, right? Or 10,000 names. You want to process. If you write a normal piece of code, what will happen? It will take little time to process it. But here by using streams, we can do right very quickly and parallel also we can do it. Right. What is a stream? Just a stream is like a sequence of data. Right. A list of data means what? That is a sequence of data. Right. That will support multiple operations. We can do multiple operations on the stream. Right. We can do first we can do sort. We can do filter. Right. Suppose I want a list. I have a list. Right. I want to filter the names based on starting with something some name. And also I want to sort it parallelly, right? I want to do multiple operations, right? At a time we can do all the operations, pipeline operations. So that means one after another we can do operations on the data and then we can provide it. We can return back output, right? We can do filtering, we can do mapping, we can do collecting, right? We can see all those things, right? Similarly, if you think conveyor belt, if you know the big companies, if you take there is a belt, we will keep the goods on it, right? It will process automatically one by one step. Similarly, here also streams of data, stream of data, we have a list. We want to do multiple operations, right? Here one by one operation it will do, it will provide the output, right? Process the, what are the features of streams? It will process the data lazily, no modification to source collection. That means it will return a new one. It will not update the source collection. Right. It supports a chaining. Right. We can do multiple operations by using chaining. Right. Can be parallelized. That means we can do operations parallelly. Right. If we have a 10,000 data, we can do parallelly. That means thousand elements. It will internally it will do. It will split into some groups. It will do the all the things and it will combine it again. So that what will happen? It will right very fastly, quickly do the operations parallel. Right, we will see some of the operations on the streams. Right, how to right how we can create a stream object. Right, how we can create a stream object. What are the different ways we can create the stream object? Right, just quickly we'll create a class stream example. Okay. Right, how to create the stream? Suppose if we have a names, this is an array. Right, suppose. Right, we can create a stream object by using arrays class. We can create a we will do this later. Just we can create the object by using arrays dot string. That means what it will return? It will return a stream of strings. It will return one string. Right. It will return a stream object. What is a stream? That if you click on it, see it is an interface. Stream is an interface. Interface what it will contain? It will contain a multiple abstract methods. Right. It has a filter. See, filter method is taking our functional interface. Yesterday's class we have learned about predicate. Filter will take a predicate. Map will take a function. That map to int, right to int function. These are all functional interfaces. Right. What is the input it will take? Stream. Stream methods will take a input as a functional interfaces. Right. Suppose it is an array, string array, or we can take any type of array. Then we can get the stream object by using arrays.stream. Suppose we want to do some operations on it. See, this is the simple operation. Filter. Filter method, what it will take? Predicate. Predicate means what? Yesterday, what we have learned? Right. It will take the input. It will return the boolean. Right. It will take the input and then it will return the boolean. Right. Here see. Right. We can predicate. How to create predicate? Right. We can create to under to get more clarity. Right. Predicate will take some input. Right. Input. And it will return the output. What type of output? It will return string. Something. Both names are same. Okay, something. Right, predicate. This is the predicate, right? Just what we are doing here, we are creating the interface of object of predicate. Simple. Yesterday, what we have learned, right? This is simple. We are creating the interface object. Right. This is one way. Yesterday, what we have learned by using the lambda expression, we can. Right. Here, what we are doing, we are taking the input, and if it starts with J, right? Then it will return the true. Predicate what it will do? It will take the input, it will return it. Just we need to pass this predicate to the filter object, or directly we can do what, right? This one directly instead of storing and right these things. Right, what we can do directly, we can store it instead of it. Right, directly we can do it. Right. Directly like this we can do it. It will return predicate only, right? Instead of storing, we can do it. Just to make you understand, just I have written like that. Right, filter what it will take? Predicate. Predicate means what? It will take the input. Right, this is the input. It is taking a name. If it starts with, it will return the true. If it is true means it will print it. Right, print also we can take that we will do normal print only. Right, so that we will understand more. Right. For each method, what it will take? Consumer. See, consumer. Consume means what? Consumer means what? It will take the input. It will, right? It will take the input. It will not return anything. Right? Consumer. Right? Right. It will just print it. It will take the input, but it will not return anything. It will take the input, print it. That's it. Right? What we are doing here? We have taken one stream, array stream. Then we are doing filter. That means what is the filter we are doing? If name starts with J, just to filter all the names. Filter all the names which starts with a J, and then print it. Simple. Print it. Right. All are started with a J only. Suppose we'll change a few other things. Right. Now let's see. Only it will print the J. Right. Here simple thing we have to, for filter we have to pass the predicate. That means any predicate you can write. This is one of the question. right? One of the scenario. I want to print all the names which starts with the J. Right, J. Right. This is one scenario. Right. What else we can do? Right. See, this is also a simple condition. This is also a filter means it will filter the data from the actual data. Right. It is the actual stream of data. From that data, we are filtering based on the condition. We are filtering the based on the condition. We are passing the some predicate. Right. Some predicate. That means this is the condition. Based on this condition, just return it. Right. If you want to return, we can write simple return stream of string. We can point to stream of string. But here just directly we are printing that data directly. Right. Printing data directly. Suppose you want to collect. Right. We'll see that later. Okay. This is one way of creating stream object by using arrays. Right. By using arrays. We can also create by using right a collection. Right. We can also create a collection. Suppose a list. Right. We can also create the list. Suppose directly I am passing this. Right. Names. Right. By using names arrays dot as list, we are creating the list object. You can create anyway. List object we can create anyway. Already I have just a simple way arrays dot as list. Pass this names to list. Same way we can. Right. In the right here we can also do on the names list same thing. We will get a names list dot list object also we can call the stream. The list object also we can pass the stream. Right here you can write whatever condition we want. Suppose ends with or starts with or right whatever we want. Right. Then suppose in middle. In middle I want to there is a one more function called map. Suppose right map. Right. I want to map to uppercase. I want to map to uppercase. Okay. Right. I want to map what it will take. It will take the predicate of function. Right. It will take the function predicate. Function means what? It will take the input. It will return the output. Right. It is taking the input as a name. Again, it is converting uppercase. It is written. Right. It is written. Right. If you understand yesterday's concept, then only it will be very easy to understand this. Right. Here we are creating a simple predicates. We are passing to this conditions. Simple. Right. Map means what it will do. It will convert the stream of data to uppercase letters. Right. It will whatever we are getting. First we are doing filter. On that it will apply to uppercase. That means it will change the each string into uppercase, either uppercase or lower. Map means that what it will do returns a stream consisting of results applying the given function. We can write any type of function. This is a function, right? Function predicate, right? Simply stream is already been operated, right? See here, see once the stream is already we have done stream, right? Immediately what it is saying, stream already used. You see this stream. See this stream is we have done all operations. We cannot on the same stream we cannot do again. On the same stream, I cannot do again. I have to create another stream. Stream can be used only once. Stream can be used only once. Right. If you want to do again some other operation, you have to create another stream. Right. Just let me comment. This is we don't require. Right, friends. Where we are printing it printed J. I think this one printed. What happened to this one? Okay, names. Okay, ends with right. We kept ends with right. There is no name ends with J. Right, we'll keep a starts with only. Starts with. Okay. Let's see, it is converted to uppercase. Right, we can use any function if you want to do lowercase or uppercase. Right, we can do it. Right, what else we can do? These are all right. We can create a stream object for the list object, collections of any collection. Right, or arrays. If we have a group of arrays, we can right here we have seen two scenarios. If we have a any array, string array, any type of array, string array, integer, boolean, whatever may be. We can convert by using arrays.stream. We can convert to stream object. On that, we can apply the right method chaining. This is called method chaining. One by one, we are calling right on the same object only we are calling. Right. Similarly, list object. Right. Mostly we will do on the arrays and list group of objects where we will store either collection or right or arrays. These two only right. We have to create a group of objects it will support. Right. Group of elements where it will support arrays and collection. On the arrays and collection only we can use the streams. Right. There are lot of right filter. Filter is the one method. Keep elements that match a condition. Map transform the each element. Right. What we have done here, it is transformed to uppercase. Right. Then sorted. If you want to sort this, right, we can call sorted. Right. We can call the sort. That means what it will happen? It will sort the based on the order. Right. See, it will sort it. Sorted means distinct. If we have a duplicates, suppose if it has a right, a list has a some duplicate. Suppose we'll see, we'll add and see. Is it returning? Chalk. Okay. Then we'll call distinct. Okay. It's removed. But is it started with J? Right? See, J only. Starts with J only. One jack only printed. Right? It's removed. Distinct. Right? A limit. Right? If you want a limit, that means I think limit what it will do. I want to limit to only one. That means it will print out of the three are returning, right? We are getting three elements, but we are limiting to only one. That means it will print only one. Return stream consisting of elements of the stream truncated to be no longer than max size. That means it will return one. One means one. If we limit to two only, that we will get two, first two. Right after doing the operations, if we want to get first one, right, first one or first two elements, three elements, we can pass the whatever we want here. Skip means it will skip the first n elements. Right, instead of limit, suppose skip. Right, we are getting three elements. We are skipping two, then it will print the last one. Right, first two it is skipped, last one is printed. Right, skip. Right, skip. Peek method, right? Peek is used to right. If we want to debug it, right? Right. Basically, we cannot debug it. If there is any issue, right? It's very difficult for us to do it. But by using peek, right, we can debug and log the each item. Right, that we'll see. Peek. Right. This is already we have seen. Then terminal operation. Right. These are all intermediate operations. Right. These are all intermediate. That means what? After starting the stream, before printing, in middle, intermediate operations. These are all filter, map, sorted, distinct, rate, limit, skip, peek. These are all intermediate operations. But terminal operations. That means terminal means at the end. At the end, one is for each. That means per print it. Just we are printing after operations, just we are printing. Right now, suppose instead of printing, right, what we can do, we can collect. Suppose I want to return to a again list. That means collect, right, what it will take, it will take a some collector object. Right, again, what I want to return, I want to return a list collectors dot to list. That means I want to return a list. I want to return a list. Right, something we'll call it as. Okay. If we want to store it back again, then just we are collect. We can use the collect. Inside a collector, we can collect. There are a lot of things are there collectors. This is a collectors is a right class. It has all the static methods. There are a lot of things. Right, you can play around all these things. Right. If you want to return the list, if you want to return the set, if you want to return to map, right, we can return any collection. Right, that is the collect. I think see two array is there. If you want to change it to two array, right? Instead of collect, we can do two array also. Right? Two array means it will return the right array object array, or directly we can point string. I think it's not allowing. It's object array. It's returning the object array. Right? We can two array will return the object array. Right? Mostly, if you want, we can do it for array, or mostly we will do for list or set. Then count if you want to count the number of elements. Right, instead of collect, just I want to what is the right count what it will return, it will return a long object. What is the count of the elements after doing all these operations? Right, what is the output of this string? Right, all these operations, what is the how many are there? Count. Right, similarly, any match, check if any elements matches, all match, none match, find first. Right, reduce. Right, suppose see, if we have an array, write a list like this, just we'll see. Right, we have a list of integer. Right, if you want to find out the filter only even numbers, you want to print the even numbers only. Right, what we have to do first, list object we have list dot stream. We have to call the stream. Then what we have to do, we have to filter the elements which are even numbers. That means I want to filter. Right, then we have to pass the filter. Filter will take a predicate. Right, that means we have to pass the condition. Right, predicate means condition that will take the input, it will return the true. Right, if it is n percentile 2 equal to 0, then it is a even number. If it is it will return true, it will return that will return that element. Otherwise, it will ignore. Then again collect back to list of integer. Again collect, that means return the list of integers. We are saying return it again. Right, just it will print the what are the even numbers here. If you want to change this condition, that's it. If you want to do right another operation, filter means just a condition, like a condition, that is you want to pass the condition. If that matches, it will return the element, otherwise ignore it. Simple. Right, fine. Right, see here we have, suppose here map also we can map. How we can use map? If you want to square the number, right, map means it will not filter, that means it will not reduce it. Right, number of elements it will not reduce. Map means what? Either you want to multiply with some number, right, you want to divide the number with something. Right, map means it will do the operation on it. It will provide new number on the existing number. It will do the operation. It will provide new number, but it will not filter means it will reduce it actually, right? It will filter it, but map just it will convert existing number into another number, another string or another number, whatever, right? Here we are doing square. That means we are squaring the each number after filter. Even numbers we are squaring it, right? It will square this. Suppose see, uh, right, I want to get the sum of all the after square, right? I want to sum. I want to return the sum of it. Right? Then what to do? Reduce. Why it is showing like this? Reduce. Okay, we have to. Right, it will return a sum. Right, just we need to change the sum. Right, reduce what it will do? It will reduce the whatever elements are there. It will combine into one. It will combine all the elements into one element. Right, what we are doing here after getting the squares, we are doing the sum of all the numbers. Right, reduce will convert all the numbers into single number. Right, here what we are doing, first number we are taking as a 0. Right, if you want to do sum, how you will do? You will take a first initially sum is 0. Right, similarly after that what you will do? Sum equal to sum plus, right, like next number, what is that? Same thing here also. Starts with 0, then add next number, add to 0. It will come the output. Then add next number to previous output. Right, like this it will do, and it will return the sum of those. Right, it will integer colon sum. Reduce what it will take? It will take a what is the initial value and then binary operator. Right, yesterday we have seen this binary by functions, right? That is different. I think this is different. Binary operator, right? Just integer colon sum. This is a method reference. What we are doing here in integer class, there is a sum method. Integer class, right? Take the sum method, right? By using reduce method, we can reduce to either we can do sum or multiply, right? We can, or otherwise see, we can do lambda expression also. Here, this is method reference. This is called as a method reference. If you want to do right lambda expression, you can do like this. Right, you can take the two variables and then a plus b. Right, right. Either lambda expression we can write or method reference. This is very simple, right? But we have to remember that's it. Right, in interview, right? We can explain filter map. We can tell. We can do the filter. We can do the map. We can reduce it. But exactly what code you will write, right? They will ask, right? Exactly what code you will write. You have to remember anyone. This is called a method reference, or you can use the lambda expressions. Right? Either one is fine. You can write either like this. Two things. If you want to do some, we need a two variables. Then lambda expression a plus b. Right? Like this. Also we can write. Right? Coming to map. Right? Coming to map. This is the right. In map we can do a lot of things. But we'll see simple ones. And we'll create one more class. Okay. Hmm. Okay. Okay, fine. Here see, we have a list. We have a list that we have created a some list. On this, what we are doing, names dot stream, collect. We are directly calling a terminal operation. Right. There is no intermediate operations. Terminal operation. Collect. Here what we are doing, collect to map. Right. Collectors dot to map. Map means we will have a key and value. Key and value. Here what is the key? Apple. Then what is the value? Length. Right. Here see, key is the name. Right. Here first we are taking, see here applied two lambdas. First one is the name. This is the key. Right. Name, lambda expression, name. Right. This is the key. Again on the name. Again on the name. This is the value. Right. Name. Get the length of the each name. Right. Now the key is each one. Apple. What is the length of it? 5. Right. Then we are collecting back to map. We are collecting back to map. That means from list to map. Right. From list to map. We got. Right. From see, from map also we can do the streams. We can map object also. Suppose this is the sorry names, right? Map object also we can do something. But if you want to do stream on the map directly, we can. There is no method on the stream. Right? There is no method called stream. Right? We have to get the collection object. That means set object or list object. We have to get it. Right? If we get the entry set. Right? If we get the entry set, we will get a set of entries. Right? Then we can do the. See here what is happening. We can get the entry set. Once we get the set or list object, we can do the stream. Right. Then on the stream, what we are doing, filter based on the value. Based on the value, right? Entry dot get value. If size is greater than 5. Right. If size is greater than 5, just print those things. That means filter. Right. Here predicate. Filter means what, it will take condition. Right. Here what we are doing, it is returning a entry object. Right. Entry object, what we will have, get key, get value. Right. We will write a conditional key or value. Here value we have. What is the value? Length of the each string. Here we want to filter. Length should be greater than 5. Length should be greater than 5. Then just we are printing it for each, and then we are printing the lambda expression. Right. On the map object, you have to get the either, right? We will get the entry set, key set, right? Then we can do the stream operations. Directly on the map, we will not get. We have to get the entry set, then we will get the key and value. Then based on key and value, we can do the filter. Right? All the terminal operation now we can call it, and then we can write end operation, whatever we want. You want to return to again map, or you want to list, whatever we want, we can use the column. Right, we have to remember these operations. What are the terminal operations? Mostly we will see these two, filter and map. Filter and map. And then end operations, these two mostly. Right. forEach and collect. forEach and collect. Collect, what it will do? It will return the either again list, set or map. Right. forEach means just it will print the data. Right. Mostly we will have in the stream, we do the stream operations on either arrays or collections. Either arrays or collections. Right. Here we will have a intermediate operations. Right. Terminal. Right. We will have a terminal and mostly intermediate terminal operations. Intermediate operation mostly we will do filter and map. filter and map. Each filter object, each method will take a functional interfaces, right? Each method will take a functional interfaces, either predicate or function or consumer, right? And terminal operation. Then we can terminate. Either we want to print it or we want to return back again, right? And there are a lot of examples I have kept here. I think these are all we have seen. Filter with, right, starts with the name. Converting to uppercase. How you will convert map, right? If you want to convert to uppercase or lowercase, we have to use the map method. But right, if you want to reduce the size, reduce means what? Based on the filter. You are reducing the, that means reduce means if you want to based on the condition, I want to, right, avoid few of the things, then filter. If you want to map the same string, I want to change it to another form. I want to change the same element to another form. Then we can use the map, either to string, right, to uppercase, to lowercase, right. Either you want to substring, right. Then we will go for a map, right. Here, see, this is count the elements matching condition, right. Here we have a list of string. We are getting the stream object, and then we are doing the filter. What we are doing, if number is greater than 25, filter it all the numbers which are greater than 25, and the count, how many numbers are there, how many numbers are there, right. If you want to find the, say, minimum and maximum, if you want to find the min and max, right, we can do a lot of things, but we have to do practice. That's it. But you have to understand the functional interfaces first, right? Yesterday's class. Then understand the what are the methods, how we will apply, when to apply filter, when to apply, right, different methods, when to apply. Those things we should know. Then only we can most we will become a, right, streams, how to use it. Here what we are doing, getting the list object. On the list, we are calling the stream. Then there is a method called max. On the stream object, we are calling a max. Then it is a method reference calling, and that means integer column. This is called a method reference. We can also write a lambda expression, but this is very simple. Integer column compare. Compare each and every element and return the maximum element. Right? What it is saying, compare each element and then return the what is the maximum element. Similarly, min element. If it is not found anything or else throw, it will throw the exception. Right, min and max. Right, we can also do, let's see, min and max values. Right, so, okay, see, it is a somewhat a little bit advanced. Flat on the map, flat map, right, a flat map concept. Actually, this is a little bit. Here we have a, see, list of list. That means I want to convert to list of list to single list. Here what it contains, list of lists. That means you have a 10 list objects. Inside a list object, you have again one more list. Right. One list object, you have again list. Let's see here how many lists. This is one list object. This is one list object. Right. I want to combine all the things to single list object. Single list object. These scenarios also we will get. That we will use the flat map. For that we will use a flat map. It is a list. We can get the stream. Then we are calling the flat map. It will take a functional interface. Right. Functional interface. Right. What it will do, collection, column, stream, method reference. Right. This is called a method reference. Collection, it is doing stream on the each list. It will do the stream. That means it will iterate one by one collection element. Each element in the collection, it will convert to single list. It will convert to single list. Flat map means return all the different types of list elements to single list element. That means, right, flat map. We can use this flat map. Right, like this, we have a lot of things. Some of the number, partition, true or false, filter, even numbers, capitalize. These things we have seen. Capital things. Count words longer than 4 characters. Right here, filter. Right, sum of lengths of names. Right, we have seen this one. Right, there are multiple things. Right, we can. Right, you can get it if you understand the what is functional interface and how to apply. What are the different methods in the streams? Right, what it will take input. Each method, what it will take. Right, what type of functional interface it will take, what it will return. If we understand that one, you can easily, you can practice, right, different types of scenarios. You can take different types of questions, you can practice on that. Right, I think, right, I am thinking I have explained something you understand, at least. Right, not 100%, at least 50% if you understand, remaining 50% you can practice. At least if you understand the concept, you can do the things. Right, fine. In the next class, we'll come up with one more topic. Right, right. Any questions?